We find a question on thermodynamics here. Of course, it is a PYQ which has appeared in various competitive examinations. The question is quite simple, but at the same time, it has to be looked properly. The question is, an amount of ice of mass 10 to the power minus 3 kg and temperature minus 10 degrees Celsius is transformed to vapor of temperature 110 degrees Celsius by application of heat. We are required to calculate the total amount of the work done for this conversion. Naturally, when heat is applied to an ice which is not even at 0 degrees Celsius, it is lesser than minus 0 and is 0 degrees Celsius and is at minus 10 degrees Celsius. Therefore, we need to consider the various heat changes when ice is transformed from minus 10 degrees Celsius to a vapor at 110 degrees Celsius. Now, let us look and pay attention to what type of conversions would be occurring when the ice is transformed from minus 10 degrees Celsius to a vapor of 110 degrees Celsius. And we shall calculate the change in heat energy in terms of either Q1 and a number of steps. So the first step is calculate heat Q1 required to raise the temperature of ice. Second, calculate Q2 required to melt the ice when it is changed to a liquid. Third, calculate Q3 required to raise the temperature of water from 0 to 100 degrees Celsius. Fourth step is calculate heat, we shall call it Q4, required to vaporize the water. And the fifth step is calculate heat Q5 required to raise the temperature of steam from 100 to 110 degrees Celsius. Finally, our sixth calculation will be adding up different heat changes Q1, Q2, Q3, Q4, Q5 to get the total heat change, delta Q total. Now, let us take up the calculations. But basically, we must know what should be the formula where heat changes are calculated. And as known to us, the finding out the Q for raise of temperature to sample, we multiply the specific heat C by mass and the temperature changes, delta T. So the formula is Q is equal to C into M into delta T. Delta T, look here, it is capital T and means it is to be used here in Kelvin. Okay, then let us go through the step one by one. The heat required to raise the temperature of ice from minus 10 to 0 would be calculated this way, and we find it is 21 joules. Similarly, second step, when we apply all the given values here regarding latent heat of fusion, we get it is 335 joules. Step 3, required to raise the temperature of water from 0 to 100, it is 418 joules. Now we have to take care about the units which are being used here. It is capital J, that is joules, and the temperature to be substituted here is in Kelvin, but the difference comes out to be the same whether you add up 273 Celsius or otherwise also. So to make it simple, we can use this way, T2 minus T1. Final temperature minus the initial temperature. And of course, the units are here. So this way, when we pay proper attention, we can get Q1, Q2, and Q3. Next step, Of course, it is here 3.35 into 10 to the power 5 joules per kg. This is latent heat of ice which is given. Then next, MC ice. This is the specific heat of ice. And finally, 4180 joules as is given in the specific heat of water. Now next we proceed to further calculations for Q4, that is mass into latent heat of steam. When you apply, the value we get is 2250 joules. And similarly, heat required to raise the temperature of steam from 100 to 110 degrees Celsius is mc into delta T. I mean, the same formula what we have taken up till now. Of course, we have to take care of the units. And if we find here 2.25 into 10 to the power 6 joules per kg is the latent heat of steam as given to us. Similarly, 1920 joules per kg per Kelvin is the specific heat of steam given to us. And then finally, if you add it up, you get the value, correct value, as 3043 joules. Well, that is our right or correct answer, which matches with option 2. Okay, thank you. There is a request in case you have not subscribed, shared, or liked our video, please do subscribe, like, and share. Thank you very much.